So we were witnessing how to derive the formula for half-life, and we know from the equation of the radioactive decay is exponential, and it can be written as n equals n naught e power minus lambda t. When the time will becomes equivalent to the half-life time, we are going to say that your remaining number of nuclei will reduce to half of its value. It means capital N will be equal to n naught over 2. So instead of n, we will be replacing n naught over 2. On right side, it will be n naught e power minus lambda t. N naught cancels out. Our value will be left as 1 over 2 equals e power minus lambda t. What we are going to do, e power minus lambda t will be moving into the reciprocal as 1 over e power lambda t. We are going to take the natural log on both the sides, and we are going to cross multiply, and we are going to take the natural log on both the sides. Now you know the property of log, whatever is present in the power वो हमेशा पहले आ जाता है. So this will be equals to what? Lambda times t will be equal to ln of e. और यहाँ राइट साइड पे क्या आ जाएगा? नेचुरल लॉग ऑफ 2. So we know natural log of e is equals to what value? It is equals to 1. आप कैलकुलेटर पे अगर टाइप करें ना नेचुरल लॉग ऑफ ई, तो नेचुरल लॉग ऑफ ई इज इक्वल टू 1. तो हमारे पास क्या फॉर्मूला आ जाएगा पीछे फॉर द हाफ लाइफ? तो हाफ लाइफ टाइम विल बी इक्वल्स टू नेचुरल लॉग ऑफ 2 होल डिवाइडेड बाय lambda. So this will be the final formula for the half life. तो ये आपको डेरिवेशन सारी आनी चाहिए, मार्केट इम्पोर्टेंट, प्लस how to find out the half life formula. What is the half life formula? That is natural log of 2 divided by decay constant. तो हमें पता है कि नेचुरल लॉग ऑफ 2 किसके इक्वल होता है? इट इज, अगर आप कैलकुलेटर पे टाइप करेंगे नेचुरल लॉग ऑफ 2, so actually the formula of half life is this: half life is equals to 0.693 divided by lambda, and lambda is decay constant. So time is equals to 0.693 divided by lambda. Is this fine? This formula will be used to find out the half life. And this is the last point of the chapter of nuclear physics. आपका यहाँ पे न्यूक्लियर फिजिक्स के कॉन्सेप्ट्स खत्म हो गए हैं. अब जो भी हमने कॉन्सेप्ट्स पढ़े हैं इनको हम क्वेश्चंस पे अप्लाई करेंगे. जी, इज दिस डेरिवेशन अंडरस्टैंडेबल स्टूडेंट्स?
Yes, sir.
Okay, shall I move onwards? Hello, shall I move on?
Yes, sir.
Yes, sir.
Okay, जी. So let's see one of the example related to it. The question and example says that there is a strontium 90, and it is a radioactive isotope with its half-life of how many years? 28 years. And there is a sample of strontium which is having an activity of 64 into 10 power 9 becquerels PQ. Question says calculate the decay constant in per second of strontium. तो आपको क्या दिया हुआ है? बहुत सिंपल से एग्जांपल है. What is provided to you? A half life is provided to you. So if a half life is provided to you, so we know we are given a time, and that time is equals to 28 years. This much time is equivalent to how much value? 28 years. So if the time is given as 28 years, first of all what you are going to do is time को आप convert करोगे into seconds. क्यों करोगे second में convert? Because we need this lambda in the unit of seconds. So how to convert this time into years into second? 28 multiply by 365 multiply by 24 multiply by 3600. So when you multiply all of these values, you are going to get an answer as 8.83 into 10 raised to power 8 seconds. This will be the value of time. हाफ लाइफ टाइम आपका इतना है, तो हाफ लाइफ टाइम में क्या होगा कि एक्टिविटी जो 6.4 है, सैंपल ऑफ स्ट्रोंटियम की जो एक्टिविटी 6.4 है, वो कितनी रह जाएगी? 3.2 इंटू 10 पावर 9 रह जाएगी. बट क्वेश्चन हमारा आंसर ये नहीं है. क्वेश्चन हमारा क्या है कि हमने लेमडा फाइंड करना है. तो वी नो द फॉर्मूला ऑफ टाइम हाफ लाइफ. व्हाट इज द फॉर्मूला ऑफ हाफ लाइफ? हाफ लाइफ फॉर्मूला इज इक्वल्स टू नेचुरल लॉग ऑफ 2 डिवाइडेड बाय लेमडा. और लैम्डा क्या होता है? डिके कांस्टेंट होता है. तो अगर मुझे डिके कांस्टेंट फाइंड आउट करना है, व्हाट आई एम गोइंग टू डू, ln ऑफ 2 डिवाइडेड बाय टाइम ऑफ हाफ लाइफ. तो यहाँ पे इसमें वैल्यू प्लग इन करते हैं. व्हाट दिस वैल्यू विल बी, ये होती है ऊपर 0.693 होल डिवाइडेड बाय टाइम आपका कितना है, 8.83 इंटू 10 raised to power 8. So this will be equivalent to the value of lambda, and solving this lambda will give you an answer somewhat like 7.85 into 10 power minus 10. And answer will be in per second. Answer will be in per second. Is this example understandable?
Yes, sir.
Yes, sir.
Okay, so this is it from the nuclear physics chapter. So we have completed the entire chapter of nuclear physics. So let's practice a bit of questions related to it. तो मैं और भी questions करवाऊंगा आपको इसके practice. अच्छा, nuclear physics, just wait a while. You can go ahead with this, the definition of the binding energy. So energy required to separate the nucleus, the energy required to separate the protons and neutrons in a nucleus completely. Next, we are going to have what data for two isotopes of uranium are given in figure 9.1. Question say there is an isotope of uranium 235. It is having binding energy per nucleon as 7.59, and both of them are provided in mega electron volt. Mega is 10 power 6, electron volt is 1.6 into 10 power minus 19. You must be knowing the value of 1 electron volt. Okay, so uranium की आपने find out करनी है binding energy. So you know we are having what formula? Binding energy per nucleon. बाइंडिंग एनर्जी पर न्यूक्लियॉन का मतलब क्या? न्यूक्लियॉन नंबर हमारे पास क्या होता है? द नंबर ऑफ प्रोटॉन्स एंड न्यूट्रॉन्स. और इससे हमने क्या निकाल लेनी है? बाइंडिंग एनर्जी. अगर बाइंडिंग एनर्जी पर न्यूक्लियॉन हमें दी गई है 7.59, तो हम बाइंडिंग एनर्जी से कैसे फाइंड करेंगे? वी आर जस्ट गोइंग टू मल्टीप्लाई दिस 7.59 विद व्हाट? विद द इट्स न्यूक्लियॉन नंबर. और न्यूक्लियॉन नंबर क्या होता है? नंबर ऑफ प्रोटॉन्स प्लस number of neutrons. So binding energy will be equivalent to what? 7.59 multiplied by 235. तो इन दोनों को मल्टीप्लाई करके आपके पास आंसर आ जाएगा. What answer you are going to get? Almost 1783 point something आए, तो 1784 में आप इसको राउंड आउट कर लेंगे. एंड नेक्स्ट लास्ट आपने इसमें फाइंड आउट करना है बाइंडिंग एनर्जी पर न्यूक्लियॉन. तो आपको बाइंडिंग एनर्जी दी हुई है, तो पर न्यूक्लियॉन आपने फाइंड करना है, तो न्यूक्लियॉन नंबर से डिवाइड कर दोगे, और इसका कैसे करेंगे? 1802 divided by 238. So this answer will be equivalent to 7.5 of 7. So here your value will be 7.57. The student, is this understandable?
Yes, sir.
Okay. Next it says, what is meant by the term isotopes? Gee, who is going to tell me about the term isotope? What is an isotope? Speak up. Different forms of same element, different forms of same element having same number of protons and different number of neutrons. The प्रोटॉन नंबर सेम होंगे बट न्यूट्रॉन नंबर मुख्तलिफ होंगे, तो वो कहते हैं कंप्लीट फिगर 9.1 तो हम पहले ही वो कर चुके हैं. So this is how this question is to be managed. Okay, this is the question related to the concept which we have just studied. The question says uranium has a half-life of 7.1 into 10 raised to power 8 years. So half-life का टाइम हमारे पास कितना गिवन है? 7.1 into 10 raised to power 8 years. Question says show that the decay constant, आपने lambda find करना है. How much is the lambda? It is 3 into 3.1 into 10 power minus 17, but the unit is in per second. So what is the very first strategy to solve this out? Yes, student, please कोई मुझे answer करेगा. What will be your very first strategy going to take place in solving this question?
Convert the years to seconds.
First of all, wonderful, we will be converting this years into seconds. So 7.1 into 10 power 8. How many seconds will be there? In 1 year, there is 365 days. And there is, in one day, there is 24 hours. Then it is 3600. So this time will be equivalent to how much? I don't know. Okay, next, whatever this value is, next we are going to use the what formula to find out the uh, decay constant. We know that decay constant is equals to natural log of 2 divided by time of half-life. We have just derived it previously. Okay, so we need to find out this lambda. When you are going to plug in all the values like natural log of 2 like 0.693 whole divided by 7.1 into 10 power 8 into 365 into 24 into 3600, what value is being revealed out of this lambda? It will be probably coming as 3.1 into 10 power minus of 17 per second. Yes, can anyone try what this value is coming or equivalent to?
3.0957
Into?
into 10 power minus 17.
Good. So it is approximately equivalent to 3.1 into 10 power minus 17. Is this fine? Yes,
Yes,
people.
sir.
Okay, next it says the sample of uranium has an activity of this 5 into 10 power 3 BQ, right? This is the value of what? This is the value of A. The value of activity is how much? 5 into 10 raised to power 3 becquerels BQ. Question says आपने mass निकालना है sample का. Find the mass of the sample. You have to find out the mass of the sample. How will this be done? First of all, we are having a value of A and we are having a value of lambda. So let's find out We are aware about the formula in the start of the chapter we studied. Activity is equals to decay constant multiply by the number of nuclei in a sample. So from here we can find the number of nuclei in a sample, that is activity divided by lambda. So activity is how much? 5 into 10 raised to power 3 whole divided by lambda is how much? 3.1 into 10 power minus of 17. Yes, student, any one of you who can tell me what will this n be equals to?
1.62 into 10 power 20.
1.62 into 10 power 20 number of nuclei are there. Now these are the number of nuclei present in the sample. We have to find its mass in grams. We have to calculate its mass in what? We have to calculate its mass in the grams. So how this mass will be found in a grams? So we studied this formula. What was the formula? Previously we did this question as well. Okay, mass in grams multiplied by Avogadro number divided by molecular mass is basically equals to number of nuclei. ठीक है? तो नंबर ऑफ मॉलिक्यूल्स के लिए नंबर ऑफ न्यूक्लियर के लिए हम ये फॉर्मूला यूज करते हैं. तो नाउ वी नीड टू फाइंड आउट m and we are having all the remaining things with us. So what are the remaining things with us? We are going to place it here. Capital N value, capital N value is 1.62 into 10 power 20, and this will be equals to mass is to be found. The value of Avogadro constant is 6.02 into 10 power 23 whole divided by molecular mass will be how much? Because we are talking about uranium, so it will be 235. So this 235 will be multiplied with 1.6 and divided by Avogadro number. So at the end, what mass we are going to get? 235 into 1.62 into 10 power of 20 whole divided by 6.02 into 10 power 23. So at the end, yes, can anyone tell me what will be the mass here with us going to be?
0.063.
It will be 0.063 and units will be in grams. The mass will be in grams. Is this understandable? So I request each one of you to please do write this formula in your notes as well to find out the number of nuclei in a sample from the mass in grams or interconverted into back. Yes, shall I move to the next question?
How is it ordered in grams when the SI unit is kg? No.
No, basically this formula is designed with the mass in grams.
Okay.
Rest, if we want to convert this into kg, so we will be dividing it further into thousand.
Okay, sir.
Okay, shall I move on?
Yes, sir.
Okay. See to the next question, question number 2. There is a copper. Copper is 66. It's a radioactive isotope. So there is a radioactive isotope. Radioactive sample is present, and it is in a shielding. You know why it's in shielding? So that rays should not be like protruding or coming outwards. They're pretty very dangerous. So this shielding is generally of lead. It is placed in a lead container. So it is producing the radiation in all the directions, right? In all the directions. But there is another sort of radiation also present, which is naturally present in the atmosphere. Can anyone tell me the name of those radiations, the radioactive radiations which are present naturally in the atmosphere? Any one of you aware about such radiations? They are called as background radiations. You would have studied in your IGCSE. background radiations. And what are these background radiations? What are the source of these background radiation? They can be, they are in the atmosphere, can be due to the cosmic rays, the rays coming from the outer space. They can be due to the radon gas because radon itself is radioactive. Radon gas present in air. It can be due to food, drink, having the radioactive material in them, rock, soil, buildings, all such materials are having what in them? They are having the radioactive material present in them. So this radioactive material is going to be these radiations which are present naturally in the atmosphere. So the radiations which are naturally occurring in the atmosphere, such radiations are called as background radiations. The radiations present naturally into the atmosphere are called as background radiation. तो ये बताने का मकसद क्या है? So let's see. Question says, state three reasons why the activity of the sample of copper 66 is not equal to the Maillard count rate. Means that it is continuously disintegrating. This sample of radioactivity is disintegrating, but this is the GM tube, the counter, which is measuring the radiation count or the number of decays happening per unit time. It is saying कि जितनी radiation decay हो रही है या जितनी radiation निकल रही है और जितना ये काउंटर काउंट नोट कर रहा है ये दोनों बराबर नहीं है. What could be the reason behind this? Yes, can anyone tell me after thinking logically what could be the reason behind it? One of
Can
the
you repeat the question?
question is this in front of you. State three reasons why the activity of the sample. Activity of the sample का क्या मतलब है? The number of decays happening per unit time. How many nuclei are decaying per unit time is known as activity. Why this activity of the sample is not equal to the Maillard count rate. Who is measuring the count rate? The GM tube is measuring the count rate. The counter which is present in at the top of it is measuring the count rate. So what could be the reason behind it?
The decay is random, so it emits in all directions, while the
Wonderful.
count rate
Excellent. So first point you are going to write about this is that radiations are emitted in all direction. Radiations are emitted in all direction. What's the second point trying to state about this? First point is radiations are emitted in all direction. Second point says there is a presence of background radiation. There is a presence of background radiation. So definitely, if there is going to be some additional radiation present, so this counter will be reading more number. So that more number will not be equivalent to the number of radiations given out by this radioactive sample. Are you understanding? So the presence of background radiation also include the discrepancy or unequivalency between the value noted by GM tube and the radioactive sample. Is this fine? And what could be the third reason? Third reason can be,
that some of the radiation is absorbed by the air.
yes, some of radiations are absorbed by some of the radiations are absorbed by air and they do not reach the detector, right? These are the reasons due to which the value. So this question actually gets repeated several times. So you must be knowing these 3 to 4 points regarding the why the value of the detector and the value given out by the sample of radioactive material are not same. So there can be an influence of background radiation. There can be the radiations can be emitted in all directions, so not being captured by the counter. And thirdly, some of the radiations are being absorbed by the air. Are you with me? Yes, student. We are only having 6 minutes,
Yes,
so we are going to
yes,
end
sir.
up after this, right? So next question says that in a time of 42 minutes, the count rate from sample of copper 66 is found to decrease from this activity to this. Question says calculate the half-life of the copper 66. So as there is a change in the activity, we will begin from this formula. I taught you this formula few minutes back that in the case of radioactive decay, the remaining activity is equals to initial activity exponent minus lambda times t. Here we can witness the given time is what? 42 minutes. The initial activity is always going to be the larger one. So initial activity is 3.62 and the smaller activity will be 1 point. The remaining activity is 1.21. So A value is going to, this is A naught, this is T. In Sari value say what we are going to find out? We will be able to find out the value of lambda. So the value of A is said as 1.21 into 10 raised to power 2. What will be A naught? 3.62 into 10 power 4 e raised to power minus lambda into time is 42. So you are going to solve this out using your mathematical skills. 1.2 into 10 raised to power 2 whole divided by 3.6 into 10 power 4. This will be equals to e power minus of 42 times lambda. So after solving this, you are going to get one value of lambda. Can anyone tell me what value of lambda we are going to get after this? So you will be getting one value of decay constant from here, right? And when you will be getting the value of decay constant, अब आपने क्या find करना है? Half life. So we know the formula of half life is what? Natural log of 2 divided by lambda. So you are going to place this value of lambda after calculation into this formula. So like reading it from the MS, I can state that value of this half-life time period will be equals to 5.1 minutes. So your final answer will be 5.1. Yes, student, is this fine?
Yes, sir.
Rest of you.
Yes, sir.
Yes, sir.
Okay.
Yes,
So
sir.
so students, we are going to stop here, right? Almost 2 minutes are remaining. Okay, so we have ended up with the nuclear physics part. Though I am going to